We're on lesson 6.3, guided practice, page 164. Feel free to read the directions with me, then I want you to pause the video and try your best on these problems and resume the video when you're ready to check your answer. Number 1, Celeste is making fruit baskets for her service club to take to a local hospital. The directions say to fill the boxes using 5 apples for every 6 oranges. So 5 apples for every 6 oranges, and I notice that is given to me in this table on the left. And then it says that Celeste is filling her baskets with 2 apples for every 3 oranges. So she may or she may not be following those directions. The directions asked her to use 5 apples for every 6 oranges. She's using 2 apples for every 3 oranges. Question A says to complete the tables to find equivalent ratios. And that's pretty simple. You know by now that equivalent ratios are simply when you take the terms and you double them and triple them. So the second boxes, I'm going to be multiplying the numbers times 2, then times 3, then times 4. So I would get 10 and 12, and 15 and 18, and 20 and 24. And remember, what I'm looking for is equivalent ratios. These are going to be times 2, and times 3, and times 4. If I double this, I'm going to get 4 and 6, and 6 and 9, and 8 and 12. And this is where it gets a little bit tricky. You were trying to find equivalent ratios. And the very first problem in the lesson, it said, specifically it said, scan the columns and look for the second term being the same. And you actually notice that right here. I'll go ahead and switch colors and make it a little bit more obvious. You notice that right here. This number right here is 6 oranges, and this number right here is 6 oranges. So they have the same number of oranges, but then notice the apples. In the original recipe, it was supposed to be 5 apples for every 6 oranges, and Celeste is actually using 4 apples for every 6 oranges. So the question says, is Celeste using the correct ratios of apples to oranges? I'm going to type it. She is not, because 5 to 6 is not equal to, and you could either say 2 to 3, or you could say 4 to 6. And that's really all you need to say there. Alright, we will go ahead and move our page down, and we will check out number 2. And again, try number 2. I'll read it with you, but then try it. And pause the video and resume the video when you're ready to check your answer. Neha used 4 bananas and 5 oranges in her fruit salad. Daniel used 7 bananas and 9 oranges. Did Neha and Daniel use the same ratio of bananas to oranges? If not, who used the greater ratio of bananas to oranges? So there's 2 questions there. I'm going to the best of my ability, I'm going to set up a little, maybe I'll use a whiteboard here. Set up a whiteboard. I'm going to show a little work. And sometimes these questions get a little overwhelming, but when it comes to a question like this, the more work you show, really, the more obvious the answer becomes. So we have some information about Neha, and we have some information about Daniel. And I'm going to the best of my ability, keep things organized here. And notice both times they gave you the ratio bananas to oranges. So I'm going to set it up as a fraction with bananas on top and oranges on bottom. And for Neha, it was 4 bananas to 5 oranges. And for Daniel, it was 7 bananas to 9 oranges. And the question is, did they use the same ratio? In other words, are these 2 ratios equivalent? So I like to put an equal sign and a question mark. And there are various ways to solve this, but one really, really quick way would be to use cross multiplication. Remember from Moby that cross multiplication states that if you multiply diagonally in equivalent ratios, that the products going both directions would be equal to each other. 5 times 7 is 35, so I'm going to write 35. I'm going to write question mark, equal sign, and 4 times 9 is 36. And those are not equal. And so that actually answers the first question for number 2. Did Neha and Daniel use the same ratio of bananas to oranges? They did not use the same ratio. There's a second question. I'll answer that in just in a second. They did not use the same ratio or equal ratios. Alright, so the second question says, who used the greater ratio of bananas to oranges? And right now I'm not sure I have enough information, so what I'm going to do here is think of a strategy. What could I do to say to think who used a greater ratio of bananas to oranges? Well, it's kind of like using that table where you want to get the oranges to be the same number. So watch what I do here. This should make a little bit of sense when we're done. If I take Daniel's term, 7 and 9, if I multiply each of those by 5, I would get 35 to 45. And I want to remember what those represent. That would be 35 bananas and 45 oranges. And I'm going to go back over here to Nihal. I'm going to work backwards. And I need to multiply Nihal's terms by 9. And you'll see why in just a minute. If you do 9 times 5, you would get 45, and that's going to be oranges. And notice now that the oranges are the same. I'll go ahead and highlight that. This would be 45 oranges for Nihal and 45 oranges for Daniel. I'm not done though, because I didn't multiply my numerator yet by 9, and I would get 36 bananas. And so here's the answer really. If they each had 45 oranges, but Nihal used 36 and Daniel used 35 bananas, then the second question would be, it says who used the greater ratio of bananas to oranges? Well, since 36 is more than 35, then you would say Nihal used a greater ratio of bananas to oranges. And it is slight, but it is there. Alright, if you did not get that one right, please fix it. If you didn't answer both the questions, please fix it now. And when you're ready, you can move on to question number 3. I will go ahead and clear and move the question up. And I don't think I need a whiteboard for this one. We'll see. Question 3 reads, Tim is a first grader and reads 28 words per minute. You can actually see that in the table here. The words are 28 and the minutes are 1. Assuming he maintains the same rate, use the double number line to find out how many words he can read in 5 minutes. Well, they set it up very nicely for you. Then you should just be able to notice that they're letting you just go along the bottom in minutes and just count by ones. 1, 2, 3, 4, 5. So this is going to be where we're looking for our answers, because it asks for how many words you can read in 5 minutes. And if it's 28 words per 1 minute, then you just double that to get how many words it'd be for 2 minutes, and that's going to be 56. And you would triple 28 to figure out how many words you can read in 3 minutes. It's going to be 84. And I'll point out something that we noticed earlier. Since we're just going by ones, you could just add 28 to each of these numbers. So for 4 minutes, it'd be 112. And really, I wouldn't even care if you skipped all these. None of these are the answer. The answer is how many words he can read in 5 minutes, and that's 140. And the fast way would have been just to multiply 28 words times 5 minutes. Either way, we followed the directions. And they give us a little bit of line here, so I would say 140 words in 5 minutes. Alright, let's go ahead and check out questions number 4 and 5. Question 4 reads, a cafeteria sells 30 drinks every 15 minutes. Predict how many drinks the cafeteria sells every hour. So once again, if you know how to set this up, you know how to visualize the problem, it's really quite easy. But if you don't set it up, it can be overwhelming to even understand what's being asked. So right off the bat, I'm going to take these terms and I'm going to write them as a fraction. And I don't know that it matters really which one's which, but I'll just write 30 drinks. For 15 minutes. And then the question says predict how many drinks. So that means we don't know. So we could right off the bat put question mark. We don't know how many drinks. And it says in 1 hour. And I'm not going to write 1 hour there. What I'm going to do is I'm going to notice that the second term was in minutes. So I want my term here to be in minutes. and I just have to convert an hour to minutes. That's going to be 60 minutes. And then the next thing I have to notice is that to get from 15 minutes to 60 minutes, I would simply multiply by 4. So now it should become pretty obvious, the strategy on how to figure out the number of drinks. If you multiply the second term in a rate by 4, you have to multiply the first term in a rate by 4. 30 times 4 is 120, so it's going to be 120 drinks in 1 hour. Alright, final question. Explain how to compare two ratios. Well, there's various ways to do this, but ultimately what we want to do here is we want to, it's kind of like what we've done in those tables a couple times. We would like to find equivalent ratios that have the same second term, then compare the first terms.